you brought up memes. We've been talking about the self, and then your story of sort of replication and persistence reminds me of the selfish gene hypothesis, which Sarah thought was a good narrative, but didn't have too much experimentation really to back it up, if I recall correctly. I don't want to put words into her mouth, but it does sound somewhat like it resonates with your own theory of what life is. So I'm wondering if you think that's fair, or if you think it's wrong in some significant way.
Is the selfish gene wrong in some significant way? No, I don't think it's wrong, but I think it's very much a collapse of a high-dimensional problem into a low one. And I think there is so much more going on. So what I mean is that matter has to make this transition from this maelstrom of grey goo, if you like, or just atoms and energy. I mean, if you think about it, go back to the origin of the universe. There's hydrogen, where go both matters, plasma, gluons. Suddenly you have hydrogen, and if you adopt that approach, you have the hydrogen produced after the Big Bang. The hydrogen collapses, produces stars. The stars burn through their fuel and explode and produce higher elements. Those higher elements do something that is the biggest transformation in the universe ever. They bring in combinatorial diversity because you can make lots of different bonds. That transition, when the first stars exploded and dumped combinatorial stuff into the universe suddenly became big. We all thought the universe is small. It's big in space, but actually we don't understand space correctly. No one I know does. I understand space, I think, probably not as wild as some crazy professors out there, but I think the universe, in terms of causal space, is small. It's only when it made chemical bonds and matter and elements that we suddenly were able to make stuff happen. And so the selfish gene is really very late in that process. The selfish gene does not correctly capture the other things that had to happen to get there, but it does correctly capture this nuance that matter wants to persist in time. So I don't think it's wrong. I just think it's super well defined for a particular part in its timeline. I remember talking to Richard Dawkins about this, and I was like, that's really great. Like, you nailed it. But what happened before? And he's like, I don't know.
So it's very fuzzy. It's toward, as you put it, toward the end of the timeline, and it kind of jumps over this step from primordial soup to replicators. And you're interested in the chemistry that arises when you have this big combinatorial space, but you don't have the replicators yet. And you're wondering what facets of chemistry lead from soup to replicators.
Yeah, I mean, if I was to put money on it, I would say that the emergence of life is this, or the emergence of complexity associated with life, or selection, whichever word you want to give, because life is extreme, actually, because we'll say aliens everywhere. I don't think that necessarily, but the fact is that stars are all over the universe, and I think the selection, wherever there's energy and matter, there's selection. And so what I'm beginning to realize is selection is everywhere, and you just need matter and energy, and you're going to get evolution in the end. For me, that's radical but obvious, and it allows us to remove this anthropomorphization of what we have on Earth and our local solar system, and we need to start looking in our universe for evidence of selection beyond what we expect for the M-class star. And with James Webb and other things, we're going to do that, and I think it's fascinating. But I do think we are at the precipice of, I mean, we understand the chemistry. Sorry, we are at the precipice of understanding that gravity operates in the entire universe. I don't think a single physicist who's in this will go, no. I think we're going to be not that far away from understanding that chemistry and biology, or the chemistry gives rise to biology, is present everywhere in the universe, and there's biology everywhere. And this idea that aliens exist, great yes or no, it's like, it's kind of a bizarre question. I argue with people about this a lot. It's like, we accept that black holes exist, and we've never seen one. We are life, and we basically go as life exists. No, you're looking at it wrong. Does heterogeneity in matter exist? Does selection exist? If those two things exist together, you will have life. Whether it's complex, whether it produces TikTok or whatever meme you want, or YouTube, I don't know. It'll be different. But the fact is, with these features, you will have life in the universe. It is not optional. It just is what the universe does.